So now let's move on to Lewis structures using molecular compounds. So just a reminder, in molecular compounds, the electrons are being shared instead of transferred. And again, we're looking to get that octet, those 8 valence electrons around each of the atoms. So first I'm going to just give you some examples, and then we'll go over the rules, and I'll show you how to draw the Lewis structures for molecular compounds. So water, we have 2 hydrogens, 1 oxygen. Hydrogen has 1 valence, oxygen has 6. So in order to get oxygen to the octet, we need 2 hydrogen atoms to be sharing electrons. So you can see there, both of the hydrogens come in with 1 electron. That gets oxygen to 8, the octet. But hydrogen is another one of those that is an exception. And instead of an octet, it is happy with a duet. So those 2 electrons between the oxygen and the hydrogen, that represents the electrons being shared, and that represents a bond. And we call that a bonding pair because those electrons are used in the bond. So instead of writing the dots, we write a line to represent the bond. So always remember, 1 line is 2 electrons. And then the dots that are left on the oxygen are called lone pairs. So we always put the dots into a pair, and because it's a lone pair. So total around the oxygen here at the very bottom is still 8. So the lines represent 2 each, so that's 4. And then 2 in both of the lone pairs, that's 8 total. Here's another example with 2 chlorines. So they both have 7 valence. They need to share 1 each to get them to 8. So there they have the 2 electrons between them. But again, instead of writing the dots, make sure you write the line to represent the bond. So 1 line equals 2 electrons. So around both of those chlorines, they both have 8, the octet. And then they both chlorines have 3 lone pairs on them. Here's another example, hydrogen and chlorine. So again, hydrogen is okay with the duet, and then chlorine has the octet and the single bond between the 2. And then here's 2 hydrogens coming together to form a bond, and they just have those 2 electrons between them, but that gets them both to a duet. So you'll never see lone pairs on a hydrogen, never. So if you go to put lone pairs on a hydrogen, that's not correct. It's happy with just a single bond. Sometimes we need more than a single bond to get us to an octet. So for example, 2 oxygen atoms together, they can't just share 1 electron each. That does not get them to the octet, so they end up sharing 2 electrons, and they form what's called a double bond. So you can see there, between the 2 oxygens, we have 2 lines. That represents a double bond, but they still have 2 electrons per line. So we have a total of 2, 4, 6, 8 around the oxygen, 2, 4, 6, 8 around the other oxygen. And one thing to note about double bonds, they are shorter than single bonds. So, and they're stronger. So shorter and stronger than single bonds. And then triple bonds are sometimes needed. Here's nitrogen. Nitrogen only has 5 valence around both atoms. And so they end up sharing 3 electrons between the 2 of them to get them to the octet. So there's the 3 lines to represent the triple bond. And again, each line has 2 electrons. So we have 2, 4, 6, 8 around one nitrogen, 2, 4, 6, 8 around the other nitrogen. Triple bonds are the shortest bonds, and they are the strongest bonds. So triple bonds are the shortest and the strongest. Single bonds are the longest and the weakest. And we have this, went too fast. This slide right here to represent that. Okay, so single, the longest, triple, the shortest. Single is the weakest, triple is the strongest. Okay, so now to get to the rules of how to draw a Lewis structure. So I'm going to draw PCl3 as we go through these rules. Whoops. So whoa. Whoops. Let's try this. There we go, PCl3. Okay. So first of all, it says to write the skeletal structure. So you just have to pick out what's going to be the central atom. And if it's not obvious what the central atom is, then I'm planning to highlight or bold what the central atom is. But here, phosphorus, there's only one and there's 3 chlorine. So if there's only one of the atoms, that's usually the central atom. So we're going to put phosphorus in the middle and then chlorines around the phosphorus. Okay, and then it says calculate the total number of electrons. So we're going to calculate the valence electrons in this molecule. So phosphorus has 5. Chlorine has 7, but since we have 3 chlorines, we've got to multiply that. So 3 times 7. So we have a total of 26 valence electrons in PCl3. So we've got to represent all 26 electrons on our Lewis dot structure. Okay, then rule 3, we're going to start placing the electrons between the atoms for bonding pairs, and then we're going to put the lone pairs around the chlorine. So I just go in and I connect all the atoms to each other. So far I've used 2, 4, 6 electrons. Right, so the line represents 2 electrons, and I have 6 so far. So I've got 20 more to go. So here, next I do is I put lone pairs around the chlorines to give them an octet. So I have 2, 4, 6, 8 around that chlorine, and then 2, 4, 6, 8 around this chlorine, and then 2, 4, 6, 8 around that chlorine. Okay, so after I get done putting valence electrons around the chlorines to give them an octet, I count and see how many I've used so far. So we're going to count all the lines and the dots. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I've used 24 valence electrons, but I've got 2 more that I need to represent on this Lewis dot structure. So if I've used all the valence on the outside atoms and I have anything left over, it always goes on the central atom as a lone pair. So I just put it right there on the central atom. Okay, so the last thing we need to do is to make sure that all the atoms have an octet. And again, there are some exceptions to that, and we'll cover that, but for now we just want to make sure everybody has an octet. So we know the chlorines all have an octet, and then let's look at phosphorus. It has 2, 4, 6, 8, has 8 valence around phosphorus. So everybody's happy, everybody has an octet. Then the question becomes, how do I know when to use a double bond? A double bond or a triple bond. So let's do another example. And we're going to draw CO2. Okay, so again, carbon, there's only one, there's 2 oxygens, so that tells us carbon is going to be in the middle, the oxygen's on the outside. Then we've got to add up the valence. Carbon has 4, because it's in group 4. Oxygen has 6, and there's 2 of them, because oxygen's in group 6. So we get a total of 16 valence electrons. So we start by adding our single bonds between the atoms, and then we go and put valence or lone pairs around the oxygens to give them an octet. So 2, 4, 6, 8, 2, 4, 6, 8. Okay, so we've given the oxygens an octet, and let's look and see how many electrons we've used. We have 2, 4, 6, 8, 10, 12, 14, 16. So I've used all 16 of my valence electrons, But the problem is carbon only has 4. So carbon does not have an octet. So what we're going to do, this is when we can now put a double bond in. So when we've used all of our electrons and the central atom does not have an octet, we're going to make a double bond, and if we need, a triple bond. So what we do is we're going to take this lone pair and we're going to share it with carbon. So I'm going to erase it and I'm going to put it here with carbon. So now oxygen still has an octet, and now carbon also has 2 extra electrons. So we're not quite to an octet yet, but I'm going to do the same thing over here. I'm going to take these electrons and I'm going to share them with carbon. So that oxygen now still has an octet, but now carbon has an octet as well. So we've got 2, 4, 6, 8 around carbon. So that's the only time you use double or triple bonds, is if you run out of electrons and your central atom does not have an octet.